Joe Dunn, would you like to go ahead and share me a part so we could go ahead and cam it?
Yeah, why don't we, so what we want to do is, let me grab the screen real quick. We just want to kind of point out the point of Onshape and how Onshape works a little bit. And, you know, interesting, I was just in Onshape collaborating with one of you in the in the chat, so we weren't even using GoToMeeting, we were using Onshape inside chatting together. But I mentioned before that you know, anyone in the world we can communicate and start using, and anyone in the world can start using Onshape immediately. And so in this case, what Uday has done is he might be the manufacturing engineer, I'm the design engineer, and we're working together. But I've just simply received a simple email, and all I have to do is click on that email, and it brings me right into the model, and it pulls it up, and I don't have to worry about what computer I'm on or where I am in the world. I'm collaborating with Uday through that link in the email, and that does work with anybody. You can share a model with anybody, anywhere. They click on it, and they'll be right in this model. I know Uday's there because I can see that, you know, if anybody's familiar with Google Docs, you would know that this is kind of similar to the way a Google Doc works, where you can be both working in the same document at the same time. And so I know that if I was to just watch Uday for a second, if I click on this is always hard to do with GoToMeeting in a single screen, but he's on his computer, I'm on mine, and I'm actually just doing a follow me to watch Uday work in the model and do some design, and we can add some chat to the window, and we could do anything, any change I make, he'll see. There's a single source of truth where it's not copies, and it's not, we don't have to worry about someone checking in or checking out the model. It just transparently works. Now, really, I'm going to make Uday presenter and let him take this over. So let me do that, and you should be able to share your screen now, Uday, and you'll just see that he's seeing the same thing on his end. So we're going from my screen to his screen, and voila, same thing. And now it turns into me instead of him up on the top. And we could have 5, 10, 20 engineers all doing the same thing in this model if we want to.
Thank you, Joe. Hello, everyone. My name is Uday. I'm the Technical Support Manager at MecSoft, and today I'll be presenting you the VisualCAMc beta, which is the fully integrated cloud-based cam for Onshape. So as Joe pointed out here, this is our foray into the cloud-based market. And as you can see here, I have a document in Onshape, and I also have a part modeled in here. So once you have subscribed to VisualCAMc by going into the App Store in Onshape, you can go into insert an element, go to add application, and you'll see VisualCAMc right in here, and you're going to pick VisualCAMc. And when you select VisualCAMc, a new VisualCAM tab is being inserted right next to your Part Studio in here, and it's loading your VisualCAM interface in Onshape, and you can just select the part that you'd like to program today. So we currently offer 2- and 3-axis machining solutions in VisualCAMc beta, and the VisualCAMc interface is loaded. Your part is accessible in the viewport here, and you can see all of the CAM interface appears over right across the top. Our workflow is going from left to right as we work through each of these setups in here, and you'll also notice that the CAM interface, the machining browser, there's 2 tabs, the machining job, which basically displays all of the CAM programming that you're going to be doing here, and also you have the tools tab where we can define different types of tools. So the part, what I have here is a prismatic part, which means there aren't any drafts or sculpted bottoms or tapers. So parts like these, we could program them using 2 or 2.5 axis machining operation. The typical workflow in here is the first step is to establish your machine tool coordinate system. So in this particular step, you are establishing your X, Y, Z axis orientation of the part that's going to be milled on the machine tool in here. By default, your coordinate system orientation is in the same orientation as the world coordinate system as you have it in Onshape, and as you can see here, the Z-axis is currently normal to this particular face. If you need to mill the part or machine the part from a different orientation, let's say consider the bottom of this part in here, you could use these controls to rotate your coordinate system as needed. So the bottom of the part is now, the Z-axis is normal to the bottom face of the part. So you can use all of these controls in here to go back and reorient the parts. I'm going to go back and set it to the world Z-axis, and I'll pick save. And this information is updated, and it's automatically displayed under the machining job. So the machine tool type is defined as 3-axis. In our next step, we're going to select the post processor. This would be the machine tool that you're going to be outputting the G-code for. VisualCAMc by default includes post for over 300 plus different machine tools controllers out there, so which covers a wide range of CNC machines that are out there. As you can see, there's a vast list of post processors in here, and you can select the post processor either by the name of the controller or the name of the machine tool from the list of posts in here. Now I'm going to choose FANUC as my controller, and I'll pick Save. The post processor information is now updated. In the next step, we're going to define our stock material. This is going to be the workpiece that you're going to be using to be machining this part out. And as you can tell, the stock dimensions are automatically established based on the extents of the part that you've designed. You could always extend the stock in here. So I'm going to make the stock larger in X and Y, offset it in X and Y by 100 thousandths, and I'll offset it by 50 thousandths in the Z axis, and you can see that the stock is automatically updated on the graphic screen. I'm going to pick Save. So you can see that each of the information that you programmed is being updated in the machining browser. In the next step, we're going to establish the work 0, which is also known as the part coordinate system origin, or the program 0. And I'm going to choose Set to Stock. We'll pick the 0 face to be the top face. I'll pick the highest Z. And for the 0 position, I'm going to pick the southwest, which is over here at the lower left corner. And this establishes your XYZ origin, which means all your machining coordinates at the toolpaths are going to be interpreted based off this origin, and your XYZ 0 is established right in here. We'll pick Save. And this information is also updated under the setup tree. In the next step, we're going to program different types of machining operations in here. So we have 2.5-axis operations, we have 3-axis operations, and also we have whole machining operations that are currently offered in our VisualCAMc beta. Now, as I pointed out earlier, parts like these, which are prismatic, where there aren't any drafts or sculpted bottoms, you could program them using 2 or 2.5-axis operations. The reason it's called 2 or 2.5 axis is as your tool moves in X and Y, it remains at a constant depth. So the first step I'm going to do is start with a facing operation in here to face it down to the thickness of the part. And this displays the machining operation dialog, which has all the interface in here. We're going to step through each of these tabs. The first tab is the selection of the tool. You can define your tool either by clicking Select Tool under an operation, or you could go directly into the Tools tab, and you could also define tools. Now, VisualCAMc offers you tools of type of ball and mills, flatten mills, corner radius. You can define taper tools, chamfer, engraving tools. You have face mill cutters, dovetail, fillet mill tools. We have drill and also center drill tools. You can define tools of different tool types. Now, for the facing operation, I'm going to define a face mill in here where I can establish the properties for the tool. I'm going to enter in the shoulder length, the flute length. So as you key in the information, you're defining your tool definition. For the facing operation, you can also establish the tool numbers, your material for the tool, your coolant type, and then you pick Save to save this information. So as I go back to the machining job, you will notice that the tool that we created is now displayed under Tools. We have a face mill, and then the properties of the tool is displayed in the tooltip window right there. In the next step, you would want to establish your feeds and speeds. This would be you can establish your spindle RPM, your cut feed rates, your engage and retract feed rates. Next tab allows you to establish your clearance. This is the safety plane for your transfer and non-cutting motions, and when this tab is active, you can actually visualize the clearance plane right on top of the model. I'm going to leave it as automatic, and then in the next tab, you can set the cutting parameters for the facing operation. You can establish your tolerance, your stock allowance, a location of geometry for cutting. You can specify your cut types, like your cut patterns, your cut direction, your total cut depth. You can also enter in your depth per cut, your step distances, and you can also control the entry and exit parameters right in here for the facing operation. So you can see there's a lot of control that's available to you. And I'm going to pick the boundary in here. So I just did a right click to select the entire chain, and it automatically selects a chain of face edge at that particular face. In selecting Generate Toolpath, compute your toolpath, you can see the Task Process Manager shows up, and there's the toolpath generated. You can toggle the display of the visibility of the toolpath on and off, so you have all the viewing controls. And then you would want to run a verification for it. So right click and then select Simulate, allows you to run a verification. And there's the facing operation being programmed with the face mill. Now at any point of time during the toolpath animation, you could select pause and then exit from the simulation mode. You could also generate a cut model in here by selecting Create Cut Model, which gives you the result of the cut material simulation. And everything is being computed on the cloud, so there is scalability depending on the complexity of the geometry that you're working on. And you can also toggle the display of the part model on or off. Okay, so we just got through a facing operation in here. The operation is programmed and it's listed under the machining job. So if you would like to make a change or modification, you can always double click on it to make the edits and then pick Generate to generate the toolpath. In the next step, I would like to go ahead and pocket this feature in here. So I'm going to go into 2-axis machining and we'll pick pocketing. And in this particular step, I'm going to pick a tool and I'm going to use an end mill. So I'm going to pick a flat mill. We'll specify the properties for the tool in here. We'll establish the shoulder length, the flute length. We'll pick Save. So I'm going to use a 1/2 inch end mill. And the process would be similar to establish your feeds and speeds, clearance, and then we'll go directly into the cutting parameters. Now if you like the default parameters that are in there, you can just skip through those tabs and go directly into cutting parameters. And you can specify the type of parameters. You have your tolerances. You can set the stock allowance in here, choose your cutting geometry. You have different types of cut patterns. You can do offset cut pattern, linear or high speed, which is like your adaptive cut pattern. Specify start points. You can specify the step distances. And I'm just going to select the chain of these edges in here by just doing a right click on this edge. It picks up an entire chain. So your selection process is a lot easier for the pocket feature. Specify the step distance. I would now specify the total depth. And if I would like to cut it in multiple steps, I'm going to specify a depth per cut in here and then pick Generate. We'll compute the toolpath. So the pocketing toolpath has been generated. You can rotate the model to view it. You can do a pan, zoom. You have all of these controls built into it. Now, if I would like to make a change, I'm just going to double click on it to edit the operation in here. And I'm going to modify the entry to use a path ramp as opposed to using just a linear motion. I'll specify a height and an angle and then pick Generate. You will notice that the toolpath with the changes have been updated, and you can notice that the path ramp motion for the entry right in here. Now once you have the toolpath computed, you can run a verification, right click and then select Simulate. Will allow you to run a verification in here. And you could always select pause and then exit to end the simulation mode. Now finally, I want to drill the holes and then profile these slots in here. So I'm going to go ahead and select 2-axis. So once we're through with the pocket operation in here, we'll do a 2-axis and a profiling. So you can see that the feature we selected is automatically pre-selected from the previous operation. And I'll still continue using the same end mill. And I'm also going to add a few additional features in here where I'm going to pick these chain of these edges in here as well for the profile operation. So just simple right click on each of these edges will automatically pick those geometries in addition to the one that we selected. And I'm going to specify my cutting direction. We'll put in the total cut depth as 1/2 inch. We'll do it in 2 passes and choose the side to be on the inside and then pick Generate. So it's going to do a cleanup around this pocket, which we left a few thousand stock in here, and then it's also going to go ahead and machine these slots in here as well on a profile operation. Now finally, I'm going to go ahead and drill these holes in here. We'll select hole machining and drilling to drill the holes. And now for drilling, I'm going to create a 3/4 inch drill tool, a drill bit. We'll specify the tool properties. We'll specify a tool length of 3 inches. I'm going to save this tool right in here. And we'll establish the feed speeds, clearance, the parameters, very similar to what we did on the previous step. And now I'm going to just select these 4 holes for the drilling operation in here. I have those 4 holes selected. My drill depth is set to 1/2 inch. I'm going to add the tip to the drill depth. So it basically ensures that it's going to be a through hole to compensate for the tip of the tool to go past it to make it a through hole. So there's our drilling operation. Let's go ahead and run a verification in here by selecting Simulate. And there's the simulation of your drill operation. Now once we have all these operations programmed in here, they're all part of the same Onshape document. You would want to go ahead and then output a G-code to your machine tool. So select the setup to output all of the operations, right-click on it, and choose Post-Process. In this particular step, it's automatically going to output the code, download it, and preview it in a text editor. And there's your posted output file for each of the operations, and you can see those tool numbers being called out for each and every operation that's being programmed in here. Now this particular file is ready to be transferred out to your CNC machine controller. You could be DNCing it, or you could be transferring across your network out to the CNC machine. So this gives you a quick workflow of how you could program 2-axis operations.